Good afternoon and welcome to our 19th annual exhibit of hydrogen and fuel cell technology. We've been here since 1995 discussing this very important branch of our energy pie, and we'll be referring to very interesting applications in the next 20 minutes. We'll be talking with Steve Jones, who's Business Development Manager at ITM Power, about on-site hydrogen production for materials handling vehicles. Please welcome with me Steve Jones.
Hi, how you doing? Thank you.
So, good afternoon, Steve.
Hi. Hi.
Steve, let's start a little bit about ITM. You've been here before, even on the stage before, but for those who don't know, could you tell us a bit about ITM Power?
So ITM Power is a UK-based electrolyzer company. Our technology is centered around PEM electrolyzer technologies. Ranges of sizes from small units for backup power or laboratory hydrogen generation, right the way up to our larger systems that are being deployed in large utility scale projects for power to gas and for refueling solutions.
Mm-hmm. Now, for me, hydrogen generation is always an important issue because we don't have a grid to disseminate hydrogen in this country. And this is an issue because whenever we have facilities up and running, we do get letters occasionally from people who say, you know, this is a very efficient fuel cell and it's green, but you guys use diesel motors to truck the hydrogen all the way over to a facility where you're operating buses or you're operating forklift trucks. And in the end, it doesn't look like the hydrogen is that green.
Sure,
you know,
sure.
Much to the displeasure of the tree huggers.
Yeah, so I mean, it's a mixture. It's always got to be a mixture, right? It's got to make economic sense, but also we're trying to do green initiatives. We're trying to lower carbon footprints. And if your hydrogen comes from what is ultimately a fossil fuel in natural gas reformation, there will always be a carbon footprint associated with that fuel, right? So what we term our hydrogen as a triple zero in terms of its carbon. So a zero carbon associated with the production of the hydrogen, because in an ideal scenario, the hydrogen is generated using renewable electrons. So you're feeding renewable power, splitting water, making renewable hydrogen. The second zero is the zero carbon associated with the transport of the hydrogen, because you're making it at the point of use, at where the vehicles are. You're not driving in diesel-powered trucks that are carrying the hydrogen. And then the third zero is the actual vehicles themselves. They're fuel cell vehicles, so the vehicles themselves are zero emission as well.
Now, Steve, you have a specific application which you've developed to the point where it really is a technology, a money-saving technology for particular markets. Particularly materials handling proves to be one of those areas where you can service a customer and not only simply achieve those 000 standards that your company is targeting, but also offer them a savings. So let's get into this materials handling. How did you get into that business, and why is the hydrogen aspect so fundamentally good for this application?
Okay, so materials handling versus a lot of other applications has got some unique points about it that make hydrogen worthwhile. Point number one is that they're captured fleet, so they're in one location, so the distribution of refueling facilities is not an issue because you're only in one location. Point number two is that predominantly in larger fleets, these things are operating indoors. So zero emissions or zero noxious emissions is a must. So immediately you rule out diesel, LPG powered vehicles, and you're down to battery powered vehicles, which is what everybody uses today. And hydrogen fuel cells have a few benefits that make the overall economic package for a customer look attractive, you know, in certain scenarios. So the fuel cells can be recharged very, very quickly. So whereas normally it takes you 5 to 10 minutes to swap a battery in a forklift truck, because these operations run 24/7, 3 shifts a day. So rather than plugging in and recharging the truck, they simply take the battery out, swap it, put a new battery in. That process takes around 5 to 10 minutes, depending on the size of the battery and all that kind of stuff. Refueling a hydrogen vehicle can take between 1 minute and 3 minutes to actually put the hydrogen back in. So there's a saving there in man hours, so that what your staff are doing is they're spending more time doing their day job, which is moving things around rather than changing batteries. So that's one of the key operational savings. One of the actual performance enhancements that you get from fuel cell vehicles as well is that fuel cells effectively perform like a fully charged battery all the time. One of the problems with batteries is you start the shift on hour number 1, your battery's fully charged, it's performing very well. In hour 8 of the shift, when the battery is at a low state of charge, that performance of the battery is actually, it declines. So you're not doing as much work in the final hour of the shift as the first hour. Whereas a fuel cell performs effectively like a fully charged battery all the time. So that one truck can do more work. So it enables larger fleets of, say, 100 forklift trucks can be downsized to maybe 90 or 95 trucks when they move to hydrogen. So not only are they removing trucks from the fleet, for every truck that comes off the fleet, there's also 3 members of staff associated with that truck because it runs 3 shifts a day. So the overall operational savings can be quite big when you're looking at large fleets.
Now, I've even heard some people in the materials handling say, you know, the first thing we realized when we started to shift was we've got more space. Not only do you need to take the battery out, but to operate one forklift truck, you often need 3 batteries to deal with the 24-hour shift. How long does it take to charge up conventional batteries, for instance? Once you take them out, it's about 8 hours, isn't it?
Well, normally what the larger fleet systems will have a battery change station. So there'll be a large station, it'll be maybe 10 meters long by 5 or 7 meters wide, taking up a lot of floor space that could ultimately have more stock in those floor space. And they have between 3 and 1.5 batteries per truck. So you've got a fleet of 100 trucks, you would have between 150 and 300 batteries within the facility, some of them charging, some of them will be in a half state of charge, so that when the operator comes to change his battery, he's always got a fresh battery there to take. And the management systems that are involved in charging these batteries can take 6-8 hours to actually, to take it from empty back to its fully charged state. So, it's another benefit of hydrogen is that the speed at which these things can be refueled. And also the footprint that a refueling point takes versus a whole battery charging station, because the hydrogen generation unit is outside, right? So you're getting more square meterage for the customer to be able to put stock.
Now, for me, it's fascinating how batteries and fuel cells can work together. Your systems operate with hydrogen and a PEM cell, but at the same time, it's not simply hydrogen. Batteries have their own fussiness about them. They don't like to be emptied to absolute zero, and they don't like to be overcharged. So how do you integrate batteries with a fuel cell in a forklift truck, and what are the advantages of using batteries and a fuel cell as opposed to only a fuel cell?
Sure. So most of the fuel cell systems that various companies are offering for a direct replacement for a battery in a forklift truck, all of them will be a hybrid system of some sort. So they will have a small battery, it's usually a lithium-ion battery or a nickel metal hydride battery in there, acting as just like your hybrid vehicles that drive around, Toyota Priuses and whatever. And the battery acts as a go-between, if you like, between the fuel cell and the drivetrain. So it helps out in those areas of peak power demands. So if your forklift truck is all of a sudden lifting a very heavy piece of equipment, that battery helps out in the system. So it makes the system more optimal and also ultimately helps the efficiency of the whole thing.
Mm-hmm. And does it improve the battery life?
The battery life of a forklift truck, can be anything from 5 years to 10 years, because you're not using it in that intense empty to full, back to empty cycle. The fuel cell is essentially keeping that battery in its optimal state of charge. So even if some of the energy that's stored in the battery is taken out momentarily while it's doing a heavy lift, for example, the fuel cell will run in the background and keep that battery in its optimal state. So a lot of the control systems that go on board these fuel cells are designed to keep that battery in its optimal state and therefore extend its life.
One of the issues that I find interesting when you build a forklift truck with conventional batteries, these batteries are heavy. And in a
That's
way,
right.
they use that weight in certain instances when they lift objects to counterbalance the weight of the
counterbalance.
objects. Okay,
right.
so, but what I've heard is that the fuel cell and battery trucks are even lighter. So you may
That's
have to
right.
weight them down.
That's right. Yeah, the guys that make the fuel cells to go inside these trucks, most of them have to add ballast, add weight to the system because of that very point. In that, totally opposite to vehicles where everybody's going for light weighting. Weight is good in a forklift truck for that counterbalance. So some companies put a big metal casting around the hydrogen tank to add weight. Other companies essentially, fill the bottom of the fuel cell with, high weight steel or lead or whatever it is to get that weight up to the same level as the battery that it's replacing. So that as far as the truck's concerned, it's not seeing any difference.
But there would then be the option, of course, if you don't need all that ballast, to keep the truck light and make it more efficient.
Yeah, and extend the time in between refills. There are certain trucks where weight is not that critical. So I know some of the vehicle OEMs are working with the fuel cell guys to say, hey, well, can we safely take some weight out of this truck and not impact on its performance and its safety, but with the added benefit of being able to increase the time in between refills.
Now you've got these systems up and running. What's been your experience? How do they? Do the workers adjust easily to using a forklift truck that uses hydrogen?
Yeah, well, most recently we ran a 6-week trial in the UK with a grocery chain called Marks and Spencer's, and it involved our mobile hydrogen refueling station was installed in their car park area, close to the indoor facility, and the trucks use that to refill, and then short trip inside to do their daily routine. And what we found was that towards the end of the 6 weeks, some of the staff were even getting in early for work so that they could get on the hydrogen truck versus the battery truck because they preferred the experience. So the feedback that we got both on the refueling side, because these guys were doing their own refuels towards the end of the trial, and actually the vehicles themselves was very positive.
Mm-hmm. I should add that if there are any questions from the audience, you can. Oh, we do have a question here. Let me pass the microphone on.
Very simple question.
Hi.
How does the cost of your product compare with the battery operated?
Yeah, good question. And especially in this industry, in the materials handling industry, they're used to high volume, low margin. So cost is everything to these guys. So we talk a lot about the CO2 benefits of the system and all those kinds of things. If it doesn't work economically, they're not willing to pay a premium for green, right? So it's a fine balance between how many trucks there are on the fleet, how many shifts a day they work. So it works best when there are a lot of fleet trucks, so 80, 100 plus trucks, and when they work 24/7. That's where hydrogen looks most promising. So it's a balancing act, and there's an economic model that's got various inputs: price of hydrogen, amount of trucks, whether it's 24-hour operation or not, and also things like what are the trucks being used for. Is the fact that the truck is able to do more work in an 8-hour period, is that beneficial to the customer? How much do the customers pay their staff? Because a hydrogen option versus a battery option is a more capital intensive option on day one, but it's the operational savings that over the total cost of ownership over a 5 or a 10-year period can pay really good dividends for the customer. So it's changing the way that they think about things and having to, you have to put more capital on day one, but then over that 5 or 10-year period, there are significant savings that can be made. So it can be, it can save hundreds of thousands per year versus a battery system. Sorry?
How much more on day one?
How much more on day one? Well, the fuel cell systems versus a battery, for example, could be 4 or 5 times the price of a battery system. And likewise, the hydrogen refueling infrastructure, depending on whether it's a purchase or a lease model, that can be quite a significant investment of maybe, €500,000 or something like that to put this in place on day one. But then depending on that mix of sizes of trucks, wages that they're paying, and all these different things, what we can do is plug that information into a model and look at what the paybacks, So, sorry, it's not a direct answer, but there are so many different inputs into that model that it is quite, specific to a certain customer. But
if there's not an immediate other question in the audience, I'd like to follow this question up with another thought in the same direction. It's the cost question. We are, with electrical trucks, without an alternative way of producing energy, at the mercy of the energy providers. And in Germany, we all know that there's a scheduled increase of electrical energy that scares the socks off of some people in industries. What you're basically working towards with on-site production of hydrogen through renewables is a way to perhaps lessen the risk involved. That is, if you're using photovoltaics, that's a calculated investment, but the average output can be calculated as well, and at some point this is going to be a net gain once it's up and running that actually starts to save you money as you go through time. The same would be possible, I suppose, certainly it is here in this country, if you buy electrical energy in quantities at off-peak time.
Sure.
If you have these acid batteries in conventional forklift trucks, you have them charging all the time, at the worst time of the day and at the best time of the day. So have you calculated any of these factors into the whole...
and it's a good point, and the on-site hydrogen is only ever as cheap or as expensive as the electricity that you use to drive the process. So we spend a lot of time working with the actual customers themselves and whether or not, because all these guys have got huge roof space available to them because the nature of their business. Some of these facilities are 1 million square feet of floor space. So they have the ideal opportunity to put in large-scale PV on the roofs, and we're talking in collaboration with a number of industrial PV installation companies to bundle the solution together and how best can one system complement the other. And so, like you said, if you're generating your own power, you then have more control over that. And like you say, in certain circumstances, it can actually help the payback periods and try and de-risk it so that you're not at the mercy of the electricity providers that are giving you this power. Second point to mention is that the distribution warehouses, particularly if it's chilled or even worse, frozen food that these companies are moving around, they are already massive consumers of energy to keep everything cold. So they're paying for their electricity in wholesale values. And if some of these supermarket chains are buying energy for the group, so their energy bills are less susceptible to fluctuations because they're buying it in bulk and they're paying wholesale prices, and they have these more direct relationships with the power providers.
Okay. Are there any questions from the audience? We have one question here.
I did a rough calculation of costs and found that hydrogen supply was a very big part of it. But I didn't look on electrolysis, electrolysis giving 30 bars from the beginning and so on. Could that be a way to solve the economic balance?
What, using electrolysis versus delivered hydrogen? Is that your question? Yeah. Well, in short, yes. The longer answer is that it depends on a number of factors. Obviously, each customer is paying a different price for their electricity, and the benefits of a hydrogen system to that customer can be more or less valuable. So, in short, yes. In certain scenarios, on-site hydrogen can be a cheaper alternative than delivered hydrogen. But the more detailed, the devil is in the detail of looking at that, yeah.
We started by talking about this application for indoor forklift trucks, but with an eye towards the future applications, for instance, delivery trucks. We have certain issues even here in Germany. For example, in Berlin, there are days where the so-called Feinstaub-Alarm, that's the diesel dust particles, it's so high that in fact it should be illegal. The legal law has been issued, but we don't follow. It should be illegal to drive delivery trucks that are conventional. So this already happens right now in Berlin. We know that Japan is very sensitive to what happens to traffic. So do you envision in the future perhaps simply using the system also for delivery vehicles in areas where the environment has been overtaxed by pollution?
Well, all the customers that are looking at hydrogen for their forklift truck fleets are doing it primarily because they're looking at the economic savings that are associated with it, and any kind of green or renewable badge that comes with that is a bonus to them. And then once they've got that renewable asset, that hydrogen production asset that they own, is that then they start to look at, well, what other added benefits, what else can we do with this hydrogen? So there are people looking at small delivery fleets. There are people looking at providing fuel cell powered refrigeration units to the trailers that these things drive around. So rather than powering the refrigeration off a diesel engine, they're saying, well, you know, we would have a hydrogen refueling station at the depot. What does it look like to change that unit out and put a fuel cell unit in there, and therefore the carbon saving that's associated with that, and the, you know, the air quality and all the rest that goes along with that. So I can see over time, as the technology develops and it becomes more affordable, and the economic case for a delivery truck can be, you know, compared to a diesel truck and actually be cost effective, that, you know, these things will sort of go back to back to back, and things like penalties for air quality in certain cities and things like that are all these fringe benefits that can go into the total cost of ownership. And once that starts to look good, then yeah, you know, why not? Let's add on more things that you can do with the hydrogen.
Steve, what I like about your concept, it's very rooted in the now. That is, we've spent decades here talking about fuel cell technology, but what you're saying is, you know, this is already a profitable, money-saving thing for clients. But with an eye towards the future, one of the fundamentals of your business is also power to gas. That is using electrolysis and creating hydrogen, and then using the hydrogen. This is something that particularly in Germany seems to be in the discussion everywhere. We have a fluctuating source of renewable energy in the form of potentially gigawatts of wind power. And already right now, we shut down windmills at times where the power can no longer be absorbed by the grid. So this is a waste. This is costly, even if it's not 100% efficient to convert that to hydrogen. 60% of that is still a 60% wind. So do you envision a large future for the concept of power to gas, and are you looking for the next opportunity to get involved in that area?
Definitely, yeah. I mean, we've just sold our first unit for the power to gas market in Germany to Tuga Group, and you know, power to gas is definitely a big item on the agenda. One of the things we've noticed about the show this year versus previous years is that power to gas and larger scale energy storage is definitely moved up the agenda, and people are really starting to speak about that. And I think that the two have some synergies. Is, you know, the whole theory behind power to gas is that you're not wasting your renewable asset, and that you're doing something helpful with the hydrogen, and you're injecting it into the natural gas pipeline. That process can only ultimately work if the effective price that you're paying for the energy to drive the process to make the hydrogen to put it into the gas pipeline is at the right level to make the economics work. Now, if there are distributed electrolyzers that are at various locations, including forklift truck refuelers, you know, these can be used effectively as dump loads for the power. So there's synergies between the power to gas rationale and fueling stations and forklift truck refuelers as well. But it only works with on-site electrolysis because it's driven from the power industry, you know, so definitely synergies for the future.
Wonderful. On that future note, we can continue the conversation at the booth of ITM Power, which is right behind us here. We've been talking to Steve Jones, who's Business Development Manager at ITM Power. Please continue the conversation at the booth. It's been a pleasure talking to you, Steve.
Thank you very much.
Thank you.